The graph of the continuous function g, the derivative of the function f, is shown above. The function g is piecewise linear from -5 to 3, and g of x is equal to 2 times x minus 4 raised to the second power for the intervals of 3 to 6. So that means that the graph is piecewise linear from -5 all the way to 3. While it's more of a parabola from 3 to 6 with the given expression that they gave us. So part A asks us to find the value of f of -5. Alright, we're given the graph of g, and as stated in the graph below, or in the prompt, the derivative of the function f is shown above. So this graph is just equal to f prime of x. So in order to truly get f of x, we must integrate what's given to us. So in order to find f of -5, we must subtract f of 1, which was already given to us as 3, by the integration of -5 to 1 of f prime of x. So in simpler terms, we can break this graph down into sections, do a bit of geometry, and to truly get the values of the piecewise linear function. So from 5 to 2, we can break this into a square, making it -9, since it's below the graph, or below the x-axis, making it automatically negative. And from 2 to 1, with this little triangle right here, we can get this value by multiplying 1/2 by the base and height. So the base would equal 1, and the height would equal 3, which just give you 3/2. And for this last section right here, this last little triangle, we're going to look at, it's the same, around the same thing, except the base is 1 and the height is 2. So this would just give you 1. So if we plug this in to our equation right here, we can find the value of f of -5. So f of 1 was, as stated, equal to 3 minus -9, -9 minus 3/2 minus 1. This would give you 25/3, making f of -5 25/3. I just realized I made a mistake while writing that equation out. It's not 25/3, it's actually 25/2. So f of -5 is equal to 25/2. So now that that's out of the way, we can finally move on to part B of this FRQ. So the problem asks us to evaluate from 1 to 6 g of x dx, or to integrate it. So in order to do that, we must look back into our graph to really break apart each section geometrically. So from 1 to 3, we can break this into a square. So it would be 2 times 2, which is just 4. And from 3 to 6, it's a bit more complicated. It's parabola. But luckily, we're given the value of this parabola, which is 2x minus 4 raised to the second power from 3 to 6. So now we must subtract, or instead add, these two values together in order to truly evaluate what B is asking. So it would be 4 plus the integral from 3 to 6 of 2x minus 4 raised to the second power dx. So it would be 4 plus the integration, which is 2/3 times x minus 4 raised to the second power. So from 3 to 6. Alright, and we would just have to substitute these values into the x. So it would be 4 minus plus 2/3 times 8 minus 2/3 times 6. Ooh, I mean 1, negative 1. And this would be 4 plus 6, giving us the value of 10. Now, part C of the FRQ asks us, on one open interval is the graph of f both increasing and concave up. So if we go back to topic 5.6, we know that f prime of x, when greater than 0, is always increasing, right? So we can tell by the graph that any of these kind of jagged, we get the idea. Any interval above the x-axis is increasing. All right, and concave up is when f of x is increasing as well. So that would be on these intervals from 0 to 1 as it's going up, and 4 to 6. Ooh, you get the idea. So we know, or we could write out that f of x is increasing on the intervals 0 to 1 and 4 to 6. D of this FRQ asks us to find the x-coordinate of each point of inflection of the graph of 5. And it also asks us to give a reason for our answers. So a point of inflection is just a change in sign. So from negative to positive or positive to negative. Now if we look at the graph, we can see that most of the time these f double prime is usually equal, or not equal, but instead greater than 0. From here as well as here. But there is an instance where this sign changes, right here at x equals 4. As
No.
from 2 to 4, f double prime is decreasing, or less than 0, and then switches to positive right here. So we can put that f of x has a, we just put POI, point of inflection, at x equals 4. But we also have to explain, so we just put because f prime of x changes signs at x equals 4.